Trigonometry. Good morning. Welcome to TMMS Productions. In this video, we are going to study trigonometrical identities advanced, that is part 3.
In our third part of trigonometrical identities, we will go to a little more advanced trigonometrical identities so that we'll have more confidence about it. So, if we have a question like prove cot theta upon 1 plus tan theta plus tan theta upon 1 plus cot theta is equal to tan theta plus cot theta minus 1. How would you start? If you want to solve, you should take the side which is more complex. Now, which one is more complex where we can perform some functions like taking LCM, etc.? It will be the left hand side. So, we will start with the left hand side. And our left hand side is cot theta upon 1 plus tan theta plus tan theta upon 1 plus cot theta. Now, before we even take the LCM, it will be wiser to convert cot into tan because we know that cot is the reciprocal of tan. So, let us take this as 1 upon tan theta and the denominator will be 1 plus tan theta as it is plus. Let us take the second ratio, that is tan theta upon 1 plus cot theta, and we will write the denominator as not 1 plus cot theta, but cot will become 1 upon tan theta. Why am I doing this? So that I can simplify it better. Now, in my first fraction, 1 upon tan theta will be multiplied by 1 upon 1 plus tan theta because this will become reciprocal. So, I will write it as 1 upon tan theta and the denominator will also have 1 plus tan theta included. So, what do we have? 1 upon tan theta is divided by 1 plus tan theta. Now, here we will write this tan theta as it is and look at the way I'm presenting the work. You must present your work as neatly as possible. Now tan multiplies here, so we'll have tan theta plus 1. See this equal to sign in line with this, plus sign in line with this. Be very careful so that you don't get confused and you do not confuse your examiner, because if you confuse the examiner you'll get confused marks and you don't want that, right? So we will come to the first fraction will remain as it is, tan theta into 1 plus tan theta, and here plus it will be tan theta multiplied by this fraction becomes the reciprocal. Are we getting it? And as a result, we will have the first fraction as it is. We can't do anything about it just now with this fraction, and plus, see how we are writing? Write very carefully. Think carefully for each step and double check. Now, we will have 1 plus tan theta. This is also 1 plus tan theta. So now we can add the two fractions. And so our denominator, which is the common LCM, will be tan theta into 1 plus tan theta. 1 plus tan theta is here, 1 plus tan theta is here. So that multiplied by tan theta will give us the LCM. Now, in our numerator here there is 1, but can you see the denominator is tan theta into 1 plus tan theta. So this 1 remains 1. Plus, look at this fraction. This had tan theta plus 1. But our denominator is not just tan theta plus 1, it has tan theta as well. So this tan theta will multiply here, and that will give us tan cube theta. Now, do we know what we have here? It is 1 means 1 cube plus tan cube theta. So, we will say using a cube plus b cube is equal to a plus b into a square minus ab plus b square. We need to factorize this because we are simplifying the fraction, right? So, if we see anything complex, simplify it. So, we factorize this. Now, using this, we will have a plus b means 1 plus tan theta, and a square minus ab plus b square will mean a square means 1 square minus ab means minus 1 into tan theta, which is tan theta, plus b square means tan square. So we will write tan square theta, and in the denominator it will be tan theta into bracket 1 plus tan theta. Now, can you see the common factor? We can cancel it, and now we have 1 minus tan theta plus tan square theta upon tan theta. Now look at your RHS. What is our RHS? Look over there. The RHS is tan theta plus cot theta minus 1, which means there are 3 terms. Now, are we having 3 terms here? No, we are having just 1 term here. But can we split it? Yes, we can. Each one of these terms is having the denominator as tan theta. So it becomes 1 upon tan theta minus tan theta upon tan theta plus tan square theta upon tan theta. Now, anything cancels? Yes. Anything else cancels? Yes. This tan theta will cancel with 1 of the tan theta because this is tan theta into tan theta. And so, we will have 1 upon tan theta, which is cot theta, minus 1 plus tan theta is remaining here. And so, we write it as tan theta plus cot theta minus 1, which is our RHS, and we will say hence proved. Have we understood this? Now, the thing is that the more you practice, more you will have the confidence. So you should pause this video and then you should write it on your own. If you cannot, then you look once again, rewind it, and then you will see what went wrong, and then you can correct yourself. Now, remember, our question said prove that it is tan theta plus cot theta minus 1. Now I'm going to show you some trick over here. Please understand that your examiner is very creative because the examiner has learned to play with all this. Yeah. So now see, the examiner may not just give you this. You know what the examiner will give you? The examiner will say that prove that don't get tan theta plus cot theta minus 1, but the examiner will ask you to move this further on, which means tan is sin theta upon cos theta plus cot is cos theta upon sin theta minus 1. And so the examiner will take cos theta, sin theta as the LCM. So he is now playing, the examiner is playing with this, and you see sin square theta plus cos square theta is equal to 1. So 1 upon cos theta sin theta and minus 1. So that is going to equal 1 upon cos theta multiplied by 1 upon sine theta minus 1, and so it becomes 1 upon cos is sec theta multiplied by 1 upon sine theta is cosec theta minus 1. So instead of giving you the RHS, that right hand side, as tan theta plus cot theta minus 1, the examiner will give you this. Now, when you have this, so you understand that tan theta cot theta has been converted into sine and cos. And so that gives you another trigo identity like this. So you see that there is no way you can be afraid of this particular topic. Remember, you should have mastery over this, which means practice this. If you practice, you will create new pathways in your brain. You will have permanent learning taking place. You will have confidence that yes, I can do it. And remember, once you have the confidence, that nervousness will go. And you will be motivated to solve this particular topic. And remember, fear makes your mind freeze. And we do not want frozen mind. We want to have active mind. So practice this as much as possible. Shall we go to the second question? Our second question is prove 1 minus sine to the power 6 theta is equal to cos to the power 6 theta plus 3 sine square theta cos square theta. Now this particular question has been repeated in so many prelim papers and so many terminals that I thought it was wiser to take it up over here. And so let us look at this question. We'll start with the LHS. Now LHS is 1 minus sine to the power 6 theta. Now can you see that here there is power 6, but here in our sine ratio our power is 2. So we will write it as sine square theta bracket cube. So 1 minus sine to the power 6 theta becomes 1 minus sine square theta whole cube, which means this is 1 cube. Now doesn't it remind you of a cube minus b cube? So in order to simplify, shouldn't we write a minus b into a squared plus ab plus b squared? So what is our a here? 1. What is our b here? Sine square. And so we will write our factors as 1 minus sine squared theta, and the second bracket would be 1 plus sine square theta plus sine to the power 4 theta. Are we getting it? Now, on our right hand side, we don't have so many sines. We have cos also. So can you see this? You remember these identities? Can you see over here? 1 minus sine square is equal to cos square a. And so we do just that. We will write 1 minus sine square a as cos square a, which means 1 minus sine square theta becomes cos square theta. Now, in the bracket here, I am keeping 1 plus sine to the power 4a together, and I am keeping sine square theta separate. Now, why do we do that? Because on my right hand side where I have to go, I don't see 1 and I don't see sine to the power 4, which means this has been converted into this. So how does the conversion take place? Now can you see this is a square of 1 and this is a square of sine square. So I have a squared plus b squared, so to speak. Now what is a squared plus b squared? Isn't this equal to a minus b whole squared plus 2ab? Now you want to work it out, just see a squared plus b squared will be equal to a squared plus b squared minus 2ab plus 2ab. Can you see that? So we have to make use of this in order to write the value of this. So this is your a square and this is your b square, which means it is cos square theta into, I'm taking a box bracket, plus this is sine square theta whole square plus sine square theta. And we are going to use this, comparing with this, to get our next step, which would now be a minus b whole square means 1 minus sine square theta whole square plus 2ab means plus 2 into these two, that is 2 sine square theta plus sine square theta, which means you have cos square theta as it is, and here 1 minus sine square theta, as we use for this cos square, we will also convert this into cos square theta, but it will be cos square theta whole square. This is cos square theta, and so we write it like so, plus 2 sine square plus 1 sine square gives us 3 sine square. So now this becomes cos square theta into bracket cos to the power 4 theta plus 3 sine square theta. Now look at our RHS. We want cos to the power 6. If we open the brackets, if we multiply, won't we get cos to the power 6 there? We got it. Cos to the power 6 theta plus 3 sine square theta cos square theta, and that is equal to our RHS. And because we have proved, we write over here hence proved. Now understand that your examiner can interchange these cos to the power 6 here. So it will become 1 minus cos to the power 6 theta here. Then sine to the power 6 comes here. So RHS becomes sine to the power 6 theta plus 3 sine square theta cos square theta. Or the examiner might just say 1 minus sine to the power 6 theta minus 3 sine square theta cos square theta is equal to cos to the power 6 theta. No matter what they do, just follow this method, just simplify. So you see that it's not a very difficult topic. All you have to do is learn to play with this. Very important. As long as you are comfortable with this, you should not have a problem proving the identities. Another one of the trigonometrical identities which normally frequents the prelim papers and the final exam papers, the board papers, is this one. And loads of children get confused for this. Now out here, the basic thing is there are two methods of doing this, but I'm taking the shortest way. We will take LHS tan theta plus sec theta minus 1, and here tan theta minus sec theta plus 1. And what I am going to do is, without converting this into sine theta upon cos theta, I am just going to look at this one and tan theta plus sec theta minus, I'm going to substitute the value of 1, as you can see out here. 1 plus tan square theta is equal to sec square theta, and so sec square theta minus tan square theta is equal to 1. So in place of 1 we write sec square theta minus tan square theta. And the denominator remains as it is, don't touch it. Okay, now in the numerator we just simplify this. So it becomes tan theta plus sec theta minus, now can you see this is like a square minus b square? So we will write the two factors. What would be our two factors? Sec theta plus tan theta and sec theta minus tan theta. upon the denominator as it is. Okay? Let us see now how we proceed for the next step. Now, in our next step, we have to look at this and we have to look at this. If this was x, x minus x into some bracket, wouldn't we have taken x as common? So we take tan theta plus sec theta, we take common. Okay? Now, for this tan theta plus sec theta, we've taken it out. So in this place, we write 1 and minus this bracket still remains here. So we'll write it as sec theta minus tan theta. Are you getting it? Now, the denominator do not touch. Leave it like that. Now, in the numerator, we have tan theta plus sec theta. And the second bracket is, now we open the bracket because there is minus sign. We will change the signs of these. This minus tan theta becomes plus tan theta. And the denominator is tan theta minus sec theta plus 1. Now look carefully, this and this bracket. Aren't they the same? Plus 1 is here, plus tan theta is there, minus sec theta. So can you see this bracket, they are the same brackets. So we cancel them. See the cancellation? You have to always start diagonally like this. Do not cancel horizontally. If you cancel horizontally means, oops, I made a mistake. No, not that cancellation. This is your division cancellation of. So we will have now tan theta plus sec theta. And so tan theta, we have to write in terms of sine and cos. Can you see on the right hand side? We have given this. Now, for your examiner, for all you know, your examiner may ask you solve this to get this. He could give you this as the RHS. So finished, then your question will be finished. Up to here, then you will say this is equal to RHS. But RHS is not this. What are they telling us? 1 plus sine theta upon cos theta, which means I have to write this in terms of sine and cos. So tan theta becomes, tell me, sine theta upon, very good. And sec theta is 1 upon, sec theta is 1 upon cos theta. So we wrote tan theta as sine theta upon cos theta and sec theta as 1 upon cos theta. And now we have to add, taking LCM. What do we have? Sine theta plus 1. And so that is equal to 1 plus sine theta upon cos theta. That was your RHS. And so we say hence proved. Okay, so we have seen the more difficult ones over here, and I think by now you got the hang of it and you are a little more confident about your Trigo identities. Now what you have to do is you have to practice these. If you think that a particular question you don't like, so you look at the solution and practice it. Practice once, practice twice. For all I know, practice 10 times. You should want to succeed. You should want the mastery over it. And mastery over this, only you can achieve. It's in your hands. It's your will, your drive, your burning desire to be confident about this, your burning desire to get 100 on 100, your wish to max the paper. That is what is going to drive you to succeed. So understand this and practice. Nothing better than practicing so that the pathways and byways and highways will be created in your brain. And ultimately, who will succeed? You. So it's very important. So practice well and all the best for all your examinations. Thank you for watching.